is learning with people.
So the first problem says, what volume of water has the same mass as 100 millimeters cubic of gold, and what is the specific weight of gold? So we have the volume, that is 100 millimeters cubic, then we have water density, that is 1,000 kilograms over meter cube, and then it's the density of gold, that you need to search it on the internet, that is 19,320 millimeters over meters cubic. First step is to calculate the mass of the gold. We do that with the density formula, that is density the same as mass over volume. We're gonna calculate mass. We don't have we have volume and we have density. So we're gonna leave m alone. It will be m is equal to density times volume.
So mass is equal to density. We're going to calculate the mass of gold, so we're going to use the gold density. That's 19,320 times volume, that is 100, but first we need to convert it to meters, and this conversion is 1. So once we have this 2 meters, we put it in our formula. So we substitute the value of volume, so the mass is going to be 1.932 times 10 elevated to minus 3. So we have the mass of the gold. When we have the mass, we can calculate the volume of water with the mass of gold. The formula is the same. We use this, but now we're not going to leave m alone. We're going to leave volume alone. Because we're going to pass this side. So it's mass over density. We have mass of gold, that is this one, and we have the density. Now we're going to use the water density, so it's going to be 1.932 times minus 3 over water density, that is 1,000 kilograms over meter cubed. It's going to be 2 minus 6. So this is the volume of water with the mass of gold. Now we're just missing one value, that is specific weight. The formula specific weight is equal to density times gravity. So we're going to use gold density, that is 19,320 times 9.81, that is gravity, and the result is 189,529.2 units.
Well, the second problem says that a submarine is submerged at a depth of 200 meters and then levels up.
Well, we have the submarine that is something like this, and then it's submerged at 200 meters. How the pressure is maintained? Well, I think that if the submarine stays like completely closed, the pressure that is inside, it's never gonna have contact with the outside part. So maybe it's because the submarine needs to be fully closed, so that the pressure inside never contacts the outside one, so the pressure maintains and doesn't change. Then they ask us what's the pressure and the total force applied to a hatch 1 meter wide and 1.5 long. So the hatch is this.
So they ask us the pressure. We have the formula is pressure. It's equal to density times gravity times height. We have the density of seawater that is 1,030 times gravity that is 9.81 times the 200 meters.
So the pressure is gonna be 2,020,860 pascals. So now we have pressure, we're gonna calculate force. With this formula, this pressure is same force over area. And we have we're gonna calculate force and we can calculate area. So we have these measures. To calculate area is same base times height. So it's 1.5 times 1, so the area is going to be 1.5 meters squared. So once we have area and we have pressure, we can substitute the forces. So it's going to be force same as pressure times area. So force same as pressure that we calculate here is 2,020,860 times area that is 1.5. The result is 3,031,290 newtons. And this is the force that is.
It says that an hydraulic press has 30 millimeters radius. This is the input one, and the outlet has a radius of 75 millimeters. So they are asking us what would be the input force to lift a truck of 1,200 kilograms. We're gonna use the Pascal principle that says that force 1 over area 1 is gonna be the same as force 2 over area 2. Well, first we need to convert millimeters to meters. This is gonna be 0.075 meters and this 0.03 meters. So once we have both the meters, we can calculate the area of both inputs. The area of the input piston is gonna be 2.82 10 elevated to minus 3 of the input one, and in the input one it's gonna be 0.0166. So once we have area 1 and area 2, we can use this formula. They are asking what's the input force to lift a truck of 1,200. So we don't know the input force, but we know area 1 that is 2.82 10 divided to 3. It's the same as force 2 that we can calculate as mass times gravity. So the mass is 1,300 times gravity, that is 9.81. The result is going to be 12,753 newtons. So we have area 1, we have force 2, and area 2. So we don't know force 1, but we know area 1 that is 2.82. And divided to minus 3 is the same force 2 that we calculate here, that is 12,753 over area 2 that is outer piston, that is 0.0176. So we have this, we multiply this by this, and then we divide it by this, and the result is gonna be force is 2,043.37 newtons. And we're done. The fourth problem says that the inlet tube that supplies air pressure to operate the hydraulic deck has 30 millimeters radius. The output piston has 64 millimeters radius. They are asking us the air pressure that should be used to lift a crane of are 2,300 kilograms.
So we need the pressure formula that is force over area. We don't have force, but we do have area. So we're gonna use to calculate force. We're gonna use the Pascal principles. That is force 1 over area 1 is the same as force 2 over area 2. So we're gonna substitute. We don't know what's force 1, but we know what's area 1 that we calculate with the 30 millimeters radius. So we convert millimeters to meters, and we calculate the area that is 2.8210 elevated to the minus 3. And the 64 is going to be 0.0128. So we have area of both pistons. Now we're going to use it in our formula. That is, we don't know force 1, but we know area 1, that is 2.82 times minus 3. It's the same force 2 that we calculate with force, say, mass times acceleration, that 2,300 times 9.81. So we multiply 2,300 times gravity, and it's going to be 22,563. Once we have this force, we're going to substitute under formula this force 2, and then area 2, that is the output piston 1, that is 0.0128, and then we're going to multiply this by this and divide it by 0.0128, and the force is going to be 4,970.9109 newtons. So once we have force, we can use this formula to calculate the pressure. Pressure is going to be force, that is 4,970.91 over the area of the input piston 1, that is 2.82 times minus 3. The pressure, it's gonna be 1,762,734.375 pascals. So this is the pressure of the input piston to lift the crane up to 2,300 kilograms.
Fifth problem says a balloon operates at altitude where the air density is 0.9 kilograms over a meter cubic. At that altitude, the balloon has a volume of 20 meters cubic. The balloon is filled with helium. The density of helium is 0.178 kilograms over a meter cubic, and the balloon weight is 94 newtons.
So the first thing we need to do is to calculate the buoyant force. Why? Because we need to know what's the force that lifts the balloon up. So the formula of buoyant force is density times volume times gravity. So we're going to use the air density because we're going to calculate the force of the air that is being applied to the balloon to lift it up. So we have the buoyant